Hello, my name is Chrysodoulos Benetatos, and I'm going to present you BachDuet, a deep learning system for human-machine counterpoint improvisation. This is a joint work with Joseph van der Stel from Eastman School of Music and my advisor Jiao Duan from University of Rochester. BachDuet enables a human performer to improvise a duet with a computer agent in the classical style. The input to the system is the human musician's monophonic performance on a MIDI keyboard, and the output is the machine's monophonic performance in real time generated by a recurrent neural network. As you can see in the figure, in each time step, the neural network decides which will be the next note of the machine's part based on the past of both the machine's and the human's parts. In order to facilitate this human-machine interaction, we developed a graphical user interface. First of all, this GUI serves as a tool to visualize the generated music. We provide two ways of visualization: piano roll and Western music notation. For example, in this figure, the upper staff and the blue piano roll voice represent the human's part, while the rest represent the machine's part. Secondly, the GUI enables the human performer to change the interaction parameters, such as MIDI device and channels, metronome speed, and neural network parameters, etc., as well as to save the generated duet in music XML format. Before we delve into more details, first we can watch a short video demo of me interacting with BachDuet. Again, my part is the upper staff and the blue piano roll voice. This is not a cherry-picked example, and since it's a real-time improvisation, I don't have any prior knowledge about what to perform and how the machine is going to react. So there will be some mistakes, and please forgive me for my bad keyboard skills. As you saw, there were many successful cadences in various keys. BachDuet can generate music on any key and perform key modulations whenever it's needed. One thing you may notice is that we don't have to provide an initialization sequence to start the generation, even though such option is available. The system can start from any random initial state. One of the reasons we wanted to develop a classical improvisation system is the absence of improvisation culture in today's classical music performance and education. Today, a lot of classical musicians either find it difficult to improvise or they can't find other people to improvise with. So our hope is that a system like BachDuet could be used both for education and entertainment purposes. Now, contrary to the majority of other interactive music systems, BachDuet is designed with classical music in mind and supports simultaneous improvisation instead of the common call and response interaction, where the machine and the human take turns instead of playing at the same time. Internally, BachDuet uses a recurrent neural network to generate the MIDI notes of the machine's voice. The neural network is trained on soprano bass duets extracted from Bach chorales. At every time step t, the last notes played by the machine and the human performer are fed into the MIDI LSTM part of the neural network, which generates the next MIDI note of the machine's voice for the time step t plus 1. The MIDI LSTM module is aware of the past through the hidden state from the previous time step, which acts as a summary of what is played so far. Additionally, we have a key LSTM module, which is responsible for predicting the current key. Our system uses the key prediction in order to determine the diatonic pitch class of the predicted MIDI notes, which leads to better visualizations in the GUI. One of the things we did in order to evaluate BachDuet was to perform subjective tests by recruiting two groups of people. The first group consisted of 13 musically trained participants, which had an above-the-average keyboard and improvisation skills. They had to interact with BachDuet in a human versus machine task and with another human in a human versus human task. After that, they had to answer a questionnaire about their whole experience. The second group consisted of 48 musically trained participants. They participated in a Turing listening test where they were asked to listen to a random selection of duets generated from the participants of the first group. They had to rate the duets and determine which of them were generated by two humans or a human interacting with BachDuet. Out of the 15 questions that participants of Group 1 had to answer, the most important conclusions were that most of them thought that the GUI is easy and intuitive to use, also that the BachDuet's output is consistent with the chorale style. Additionally, a very important conclusion is that they thought the machine and the human had relatively equal roles in the improvisation. This means that the information flows from both players to the other, and that BachDuet is not just a passive accompaniment system. As for the use of BachDuet as an educational tool, most of the users were positive, and especially if we could improve the system by including a real-time mistakes detector, for example, voice leading mistakes, which could provide the users with feedback in order to improve themselves. However, most of them felt that the key prediction needs to be improved, and also most users rated higher their interaction with the other human rather than with BachDuet. As for the results of the Turing test, interestingly, the human versus machine duets received better ratings. However, the difference was not statistically significant. We can also see in the confusion matrix that on average, the participants couldn't predict the correct labels of the duets, meaning that the quality of both categories was similar. Here, I extracted two small segments from the highest rated duets from each category. Let's see if you can label them correctly. Okay, so the first one was generated using BachDuet, where the machine's voice was played by the cello part, and the second one was the human versus human. Let's close with some limitations and possible future work. First of all, the system requires a fixed tempo, which is imposed by a virtual metronome included in BachDuet. Also, currently, the training data limit the style of the generated duets, and we plan to include a more diverse dataset in the future. Additionally, the fact that currently BachDuet supports only MIDI inputs prevents the usage of any acoustic instrument. Finally, the interaction with BachDuet is kind of impersonal. Musicians are used to improvise in a more interactive setting, where visual cues are important and affect the final result. And currently, BachDuet does not support this kind of interaction. As a conclusion, we can say that duet counterpoint improvisation is a feasible but difficult task for classical musicians. Secondly, even though they prefer interacting with another human musician, users find BachDuet a good partner for duet improvisation. And finally, musically trained listeners were not able to distinguish between duets generated using BachDuet versus duets improvised by two human musicians. Thank you very much for your attention.